This is the second lecture on summation and series. We will continue from what we have done in the previous class. Okay, differential equation is nothing but this is a differential equations. Now this is just a mathematical model, where we express equations or functions expression or expressed in terms of derivatives of unknowns, derivatives of unknown quantity. Okay, examples are y dash, y double dash, etc. D square y by dx square plus 2 dy by dx plus 3 equal to 0, anything. Now here y is the dependent quantity, it depends on something, and which is x, which becomes the independent. That means we are varying x and how it varies with y. I mean y, how it is varying with x, this is what is. And now here there are few things like order of the derivative. Now in a differential equation, let's take for example d square y by dx square plus dy by dx plus y equal to 0. Now for this we have independent variable. Now what do you mean by independent variable? Independent variable is what is called x here. It is independent quantity. Okay, now who is depending? Now depending. Okay, who is depending variable? Dependent variable, that is y. Why it is called depending variable? Because we can write the solution of this equation as y equal to y of x. So y depends on x in this differential equation. Okay. Similarly, we can once you got y, we can also write y in terms of x in terms of y also, because if x depends on y or y depends on x, x should be depending on y if you inverse it. Okay, so likewise in that case, if I write x equal to x of y, here x is the dependent variable, and y is the independent variable. Okay, so this is what is meant by independent and dependent variable. Now what do you mean by ordinary differential equation? Whatever we are going to discuss here is ordinary differential equation. Okay, so it contains, now ordinary differential equation means it contains only one independent variable. The differential equation contains only one independent variable. Now there is something called a partial differential equation. Partial differential equation, it contains more than one independent variable. So this partial differential equation, we have more than one independent variable. So what it contains? So it contains more than one independent variable. So more than one independent variable. Okay. Order and degree. Now what is the order means? Order means the highest power. Oh no, so it's not power. You can just say order itself, highest order. Highest derivatives. You can, for example, if I say y dash, it is first derivative. Y double dash, second derivative. So this is first order. This becomes second order. Okay. So highest derivatives present in an equation or an expression. Okay. Highest derivative present. Okay. Fine. For example, in the previous example, what was the example? Okay, let us take another one. D square y by dx square plus 5 dy by dx plus 6y equal to 0. Now in this case, highest derivative present is, this is the highest derivative present. So this is how, what is the order? Order is 2. Now what do you mean by degree? Degree is the power of highest order. Now order is the highest derivative, power is degree is power of highest derivative. Okay. Power of highest derivative. Okay. Now in this case, this is the highest order, and its power, it is raised to power 1, right? So that is 1. So here the degree is equal to 1. For example, if I write d square y by dx square whole to the power 1 by 2 plus 5 dy by dx plus 6y equal to 0. Here the order is again 2. Order is again 2, and the power is also 1. Now this is because you cannot express the highest order in fractions. Cannot express in fraction. Cannot express in fraction. That is why it becomes 1. So when we have such equation, what we will do, we will just square it and make this differential form in the power 1. So for example, if it was 3 by 2, when we square it, it becomes 3, right? Then the power would become 3. So it cannot power, we will write here as a note, expressed in integral form. before going into the first order and second order differential equation, let us understand something about the differential equation, that is the order and degree of differential equation. Now let us take the differential equation example. Let us understand this by using a differential equation, just taking an equation example, that is d square y by dx square whole to the power 2 by 3 plus dy by dx to the power 3 by 2 plus 5y equal to 0. Now here, what do you mean by order of this differential equation? Order is defined as how much time the y is being differentiated. Maximum times the y being differentiated here is twice. So 2 is the order. So how much time the differentiation happens? That is twice. So the order of this differential equation is 2. Now once you got the order, now you need to find out the degree of this differential equation. Now degree is the power of highest order. Now we understood that this term is the order of this differential equation is 2, and now look at the power of this differentiation, that is to the power 2 by 3. Now highest order degree, this is, we have to write it as 2 by 3, but this cannot be done in a fraction. Degree cannot be in a fraction, so it's not possible. So what we have to do is we have to find the common factor and multiply by it. So it is 2 by 3 and 3 by 2. So just multiply by 6. What you are going to get is when you multiply by 6 you get 4, and here when you multiply by 6 it gives you 9. Oh, wait a minute, this will be 6, right? Sorry, 9, that's again 9. All right, now so our equation changes to something like this: d square y by dx square whole to the power 4 plus dy by dx whole to the power 9 plus 5y whole to the power, we are multiplying by 6, so this is 6 equal to 0. Fine. Now this now we have to see the order is 4, order is 2, and the power of the order, maximum power, is 4. So here the degree is 4. Now let us understand the difference between linear differential equation and non-linear differential equation. Now for linear differential equation, the properties are: the degree of this differential equation must be equal to 1, and the order of the differential equation can be any number. So it can be 1, 2, 3, 4, etc. Now another thing, that condition that must the linear differential equation must satisfy for the differential equation to become linear is that the coefficient must be constant. That means coefficients must be constants. Okay, now this is the 1, 2 and third point. Now what does this coefficient must be constant means? Like d square y by dx square plus 2 dy by dx plus y equal to 0. Here you can add 3 or some k here. So this 3, 2 and k must be constant. Okay, so these are constants. Now, or either those coefficient must be constants, or function of independent variable, or coefficients must be function of independent variable. Now for that we have an example, that x square d square y by dx square plus 2x dy by dx plus y equal to 0. So here the coefficients x square, x and 1 are these are functions of x, which is independent variable. Now coming to non-linear differential equation, either the degree of this differential equation must be greater than 1, and order can be any order. There is no condition on order, it can be any value. And about the coefficients must be functions of the dependent variable. So if such coefficients are present in the differential equation, then this is a non-linear differential equation. So for an example, you can write it as 1 by y square d square y by dx square plus 1 by y dy by dx plus y equal to 0. Okay, so here the coefficients are the functions of dependent variable, thus they are not linear differential equation. Now here one more thing, let us do few problems. D square y by dx square whole to the power 2 by 3 plus dy by dx whole to the power 3 by 2 plus 5y equal to 0. Now what are the power terms here? 2 by 3 and 3 by 2. Now just we need to multiply by the coefficient terms. Okay, coefficient terms so that it becomes 1. Both here also it should be integral form. So 2 by 3, when you multiply by 6, it becomes 2 into 6 by 3, that is 4. And the first term will have the power 4. 3 by 3 into 6, 8. 18 by 2, that is 9. Okay, fine. Yeah. Okay, so the power is,
order is, this is second order because d square y by dx square, so order is equal to 2 and the power is 4. Fine. Power or degree, that is what we need to remember. Ordinary differential equation. Ordinary means it contains only one independent variable, only one independent variable. Okay, so one independent variable, generally we will write the x as the independent variable. Example, d square y by dx square plus 3 dy by dx plus 6 y equal to 0, or simply dy by dx equal to x, something like this. So here y is a function of x, y is a function of x, only one independent variable. Now what do you mean by partial differential equations? Now in the case of partial differential equations, you have two or more independent variables. Sometimes z is equal to some function of x comma y, or y is equal to some function of x comma t, like a is equal to a e to the power I kx minus omega t. So it's a function of both x and t, something like that. So some function, if it is a f is some function of x comma y, then we can write the partial differential equation as dou square f by dou x square plus dou square f by dou y square equal to 5x or 5xy, something like that. Now again, if you have a potential in a three-dimensional Cartesian coordinate system, here if you write v of x, y, z, then electric field is given by minus del v, that is nothing but E equal to minus del v, that is minus dou v by dou x plus minus dou v by dou y minus dou v by dou z. Fine. And again you can write del square v equal to 0, Laplacian. This equation is called a Laplacian equation. So like that. So what is the difference between the ordinary differential equation and the partial differential equation? This, in ordinary differential equation, you have only one independent variable, that is x, or you can write y is equal to f of x. But in the case of partial differential equation, you have either two or more independent variable, two independent variable, as in the case of a wave equation, a to the power I kx minus omega t, where x and x and t are the variables. And in the case of potential, here v as a function of x, y and z, this x, y, z are the points in the coordinate system, basis of the coordinate system, and this del square v equal to 0 is a Laplacian equation. Just for remembering, please keep in mind. Okay, there are two cases. One is a linear and non-linear. Now in the case of linear, we have degree equal to 1, and here degree is greater than 1. Now in the linear case, this order can be anything. Order can be some nth order, it is acceptable, and here also any order, nth order derivative can be used. But here remember, this is linear or non-linearity is given by degree mainly, and let us see a few examples. Some constant an into nth derivative of y plus an minus 1 into n minus 1th derivative of y. It goes on. Okay, so this is an example of degree 1. This is the highest order, its degree is 1, so that is linear. Okay, otherwise another condition is the coefficient must be constant. Coefficient of the derivative must be constant. That means in this case an minus 1, all these things should be constant. One example is d square y by dx square plus 5 dy by dx plus 3y equal to 0. This is an example of coefficient equal to 0, and this is and or the constants, or what you say, the coefficient must be functions of independent variable. Generally x. Example, x square d square y by dx square plus 2x dy by dx plus 2y equal to 0. This is also an example of linear differential equation. Okay, now let us come to the non-linearity. Okay, non-linearity, one condition is either degree should be greater than 1 or the coefficient of the derivative is function of dependent variable. I'll give you an example, dependent variable. Now good example is d square y by dx square plus y dy by dx plus 6y equal to 0. Now here this second term is the problem, otherwise this would have been a linear differential equation. Since the coefficient is y, we cannot go forward. Either y or 1 by y or function of y. This is just written function of dependent variable. You will just, if you want, you can mention it as y, but you should remember y is a dependent variable, and in this case you can just represent it as function of x. Okay. Yeah. First order means the order is 1, dy by dx, dx by dt, something like that. So general form I am writing, general form of linear differential first order first degree. So dy by dx is equal to f of x comma y. Any thing it can be formed, or you can also write it as m of x comma y divided by n of x comma y. In general form you can write either f of x comma y or m of x comma y divided by n of x comma y. Now m of x comma y, just you write it as equal to dy by dx. So you can write m of x comma y times dx minus n of x comma y times dy equal to 0. Or if you want this to be written as plus, then also you can write it as plus also, and only thing you need to change here, put one minus somewhere here, it will be then. Now we are focusing on solutions, how to solve a differential equation. Now type 1, that is variable separable method, separating the variables, that is the first thing that we know. Now we know dy by dx is equal to m of x comma y divided by n of x comma y. Now if this m of x comma y, this first term, is a function of x, and this n of x comma y is some function g of y, then this differential equation can be solved using a method called variable separable method. Okay, we are separating the variable and integrating. So then you can write the dy by dx as f of x divided by g of y, some functions of x and y, which implies just put g of y dy minus f of x dx equal to 0. Now what you have to do to solve, you can solve using just integration. So integration g of y dy minus integration f of x dx equal to, instead of 0 you get some constant c. Okay, now just for example, dy by dx equal to minus x divided by y. So this is nothing but x dx plus y dy equal to 0. When you integrate, this becomes x square by 2 plus y square by 2 equal to some constant c, and this is, you can write it as x square plus y square equal to some constant. Now this is equation of circle. In general case, you will be asked to find out not the solution, they won't ask the solution, but some points will be given. For example, 1 comma 1, at 1 comma 1 what is the value you are getting. So you have to put x equal to 1, y equal to 1 and find what is the constants. Something like that will be the question. One problem is dy by dx plus 5y equal to 0. You are asked to find, you are given the initial condition. Okay, initial condition is y of 0 is given, y of 0 is equal to 1, then find y. Okay, so let's begin. So here immediately we can just shift the 5y to the left. You can write dy by dx is equal to minus 5y, then bring the dy by 5 times y over here, or keep the 5 there and make it 5 dx. This will also do. Okay, so dy by y equal to 5 dx. Now we have separated the variables. Now then integrate. So this is log y, so that's equal to 5x plus some constant c. Now in this kind of problems, if your dependent variable is a function of y, function of log, then you need to write the constant also some function of c. So that's why. Okay, now just remember, if dependent variable is function of log or any other functions, then it is better to write the constant is also as a function of log. Okay, so rewriting the equation that we have got right now, we can write log y equal to 5x plus log c. Okay, now it is given y of 0, that means y at x equal to 0 equal to 1. So log log 1 equal to at x equal to 0, right? So 0 is equal to 0, and this is plus log c. Now log 1 equal to log c means c equal to 1. Fine, then once again we can write log y is equal to 5x plus log 1, you can write it as log 1, that is 0, right? So now what you can find, log y equal to 5x. Now e to the power and log y just is equal to e to the power 5x. Now this e to the power log y, you can write it as y, so y is equal to e to the power 5x. So y is given as e to the power 5x. Now sometimes you may be in the question, you may be asked to find out y of 0 is given, so y of 1. So what is y of 1 then? E to the power 5. Solution to differential equation. This is what we were doing so far. Before going into the applications of differential equations, let us do some questions that will help us to understand more about this solution to the differential equations. Okay, so let's take an example here. Dy by dx plus xy at y of naught. Y of naught means at this is equation is on derivative on x. Y of naught means y at x equal to 0. Please remember that is equal to 2. So this is the initial condition given. What is this? This is the initial condition, because without this initial condition we cannot get the actual solution. We will be getting in terms of some constants. So initial condition. Okay, so how to solve this? We were using variable separable method. Same thing we will use here, variable separable. So dy by dx is equal to minus x y, and here dy by y is equal to dy by y equal to minus x dx. Then now it's time for integration. So integral dy by y is nothing but log y, that's equal to minus x square by 2. Now as I said, since y is a function of log, your constant should be a function of log c. Now this is our equation, log y equal to minus x square by 2 plus log c. Now bring this initial condition. Now once we get this, our aim is to find out what is c. Now at x equal to 0, now just put x equal to 0 and c, which implies log y is equal to minus at x equal to 0, y equal to 2, right? So log 2 is equal to put x equal to 0 here, which means 0 minus 0 plus log c, which means c is equal to 2. Log 2 equal to log c means c equal to 2. Now once we get this, you can write this equation of the form log y minus log c equal to minus x square divided by 2. Now log y minus log c is nothing but log of y by c equal to minus x square divided by 2. Now I have to write this c as c is equal to 2. We already got it. So log y by 2 equal to minus x square by 2. Now the last step, I wanted to write remove this log because I wanted y in terms of x. So e to the power log y divided by 2 equal to e to the power minus x square divided by 2. Now this is e to the power log is nothing but y by 2. So y by 2 equal to e to the power minus x square divided by 2, and y is equal to 2 e to the power minus x square divided by 2. So this is the c, which is constant, this is y, and what you are asked to find out? Yeah, you are asked to find out just the solution. So sometimes in the question paper you will not be asked to find out y, you will be asked to find out y of half. Then what you have to do, you just have to put this half, x is equal to half here, and write whatever answer you are getting. Okay. Similarly, we can do one more problem. Let's dy by dx equal to minus x divided by y. Now again we can use variable separable method. So dy times y equal to minus x dx. Now integration y square by 2 equal to minus x square by 2 plus some constant c. Now you can bring this or multiply by 2 and bring this x to the left, so it becomes x square plus y square is equal to 2c. Now for time being, let us take okay, here initial conditions are not given, so y of naught is not given, so let's forget about that. So this is how you can solve a differential equation. If you want to find out c, definitely you need initial condition. Without initial condition, integration constant of integration cannot be calculated. Okay, now first order, first degree applications. There are different applications like Newton's law of cooling, Newton's law, radioactivity, then time dependent Schrodinger equation. These all are first order, first degree differential equations. Okay. Then again in electromagnetic theory we have Ohm's law, sorry, not Ohm's law, it's Coulomb's law. Coulomb's law in differential form. Okay. Okay, let's see one by one. So time dependent Schrodinger equation. So how can we write time dependent Schrodinger equation? This you will be using in quantum mechanics very regularly after once we do Schrodinger equation part. IH cross dou psi by dou t equal to E psi. I will explain all the quantities. H cross, as you know, Planck's constant by 2 pi. E is the energy of particular state, and psi, you know, wave function. T is time. Okay, now this is, we can write it as dou psi by dou t equal to E psi divided by I H cross. Now bring this psi to the left, so it is dou psi by psi is equal to E dt by IH cross. So integration, once we have separated the variable, just integrate. So this is log psi is equal to Et divided by IH cross. Again here log psi will come, log some constant you have to use because psi is a function of log. So log psi naught. So this is the some constant. Now this we can write it as now again let us define what is psi naught. Psi naught is at t equal to 0 psi is equal to psi naught. That means when time is 0, that means initially our wave function psi is this, which is constant. That means in the beginning we have a psi which is equal to psi naught. That means for example the basis like any other wave function, Schrodinger wave function, for let us take it for 1D box, root of 2 by L sine kx. Okay, so this is psi naught because there is no time function. Okay, now this is my initial condition. That means at time t equal to 0 psi equal to psi naught. Okay, fine. Now the second how we will proceed, we have written log psi equal to e t divided by I h cross plus log psi naught. Now bring this to the left, log of psi divided by psi naught equal to et divided by I h cross. Fine. Now how will you remove this log? Just express it as e to the power something. So here also e to the power something will come. So psi divided by psi naught is equal to e to the power et divided by I h cross. Now if this I is in the denominator, I am multiplying and dividing by I in the numerator. So how I can do that? Et divided by I h cross. I am just multiplying with I on numerator and denominator. It becomes minus I et divided by h cross, because I into I will give you minus 1. So this minus 1 I am just putting it in the numerator. So likewise if I do that, it becomes minus I et divided by h cross. Now psi wave function at some time is equal to, as a function of time, just to indicate it is a function of time I am writing t, psi equal to psi naught, that is the initial wave function, e to the power minus I e t divided by h cross. So this is it. So now if you put a time t is equal to 2t or 2t naught, you will get another wave function. Just you have to substitute it with something. Okay. Radioactivity is another example of first order, first degree differential equation. So how we can write? If there are n naught number of particles, number of atoms after a certain time t, then there will be n number of atoms left, correct? N number of atoms left after t time, which means and this n depends on, n will be a function of n naught as well as time t. So how can we write the radioactivity equation? That is minus dn divided by dt is proportional to n. So changing the number of atoms is proportional to initial atoms. That means how many atoms are present in the, now this minus sign indicates there is decrease in the number is decreasing. So how we can write this as dn by dt is equal to minus lambda times n. Now what is this lambda? Lambda is nothing but the decay constant. Okay, yeah, fine. Now so this is our differential equation. Now using the variable separable method, you can solve this. How we can solve this? Dn divided by n is equal to minus lambda dt. So immediately you can integrate this. What you are going to get is log n is equal to minus lambda t plus log n naught. I will write n naught because at t equal to 0 I know n will be equal to n naught, where n naught is initial number of particles. Okay. So at t equal to 0 I can write log n is equal to, here put t equal to 0, I will get 0 plus log n naught. Right, which means n equal to n naught at what? At t equal to 0. Fine. Now writing this equation again, log n equal to minus lambda t plus log n naught. Bring this log n naught to the left, which becomes log n minus log n naught equal to minus lambda t, which means log of n divided by n naught equal to minus lambda t. Just put e exponential form. E to the power log is nothing but 1. N divided by n naught equal to e to the power minus lambda t, and n equal to n naught e to the power minus lambda t. This is decay equation or radioactivity equation. The same way, it is solution to differential equation. We are using the separable method. So dy by dx is equal to y square divided by x. Just as we have done earlier, dy by y square equal to dx divided by x. So simple integration, what you get is minus 1 divided by y, nothing, this is y to the power minus 2, y to the power minus 2. When you integrate, you will get minus 1 y to the power minus 1. That's all. Okay, so 1 minus 1 divided by y equal to log x plus c. Now why we are not using log c? Because our y is not a function of log, only our x, that is our independent variable, is not a function of x. That is why we are not using. Okay, so one condition is given, y of 1 equal to 1. Just now put y of 1, so minus 1 divided by 1 equal to log 1. Log 1 is 0 plus log c, so which means c equal to minus 1. So now we got that. Now the coming to the second part, once we got c equal to minus 1, you just substitute there. So minus 1 divided by y equal to log x minus 1. So y is equal to minus 1 divided by log x minus 1, or you can write 1 divided by 1 minus log x. Now y equal to 1 divided by 1 minus log x. Now we are asked to find out the domain range of x. What are the values x can take? Now immediately you can write x cannot be 0, right? Cannot be 0. Why? Because log of 0 we don't have. Now x, that means log of 0 is 0, so 1 minus, so this should be always giving you a positive value, log of a positive number. So x is always positive also, because log of negative number we don't have, negative log we don't have, so log x should be always positive. So these are the two conditions, cannot be 0 and it is always positive. So x is greater than 0 is the answer. So this is a jam question. Here I don't know, but still it's a jam question. Yeah. So here what we have, so df by dx is equal to 3 minus 2f, 3 minus 2f, well and good. So df by 3 minus 2f is equal to dx. Okay. Okay, so I will just multiply here with minus 2 because I want its differentiation in the numerator. So here also I will multiply by minus 2. I hope this is fine. So log of 3 minus 2f equal to this minus 2x plus log c would come. I hope this is fine. Now initial condition at x equal to 0, f is equal to 0. Now put f and x equal to 0 in the given equation. So log of 3 equal to log c, and here c is equal to 3. So that's what we got. Now once again taking this equation with c replaced with 3, so log of 3 minus 2f equal to minus 2x plus log 3. Now bring this 3 to the left side, what you are going to get is log of 3 minus 2f divided by 3 equal to minus 2x. So this you can write e to the power, then what you get is 3 minus 2f divided by 3 equal to e to the power minus 2x. Fine. So from here you can get 2f, 3 minus 2f is equal to 3 e to the power minus 2x. 2f minus 2f is equal to 3 by 2 e to the power minus 2x. F is equal to sorry, this is 3 e to the power minus 2x minus 3 would come, then minus f is equal to minus of 3 e to the power minus 2x minus 3 divided by 2, and this you can rearrange. 3 you can take it out, 3 by 2 into this minus, when it goes inside this becomes plus and this becomes minus, so 1 minus e to the power minus 2x. 3 by 2, 1 minus e to the power 2x. Now the question is find f of 1. Now put x equal to 1. So 3 by 2 into 1 minus e to the power minus 2. So this is equal to f of 1. Now I am writing here dx1 divided by dt equal to x2 minus x1. Now please listen, x1. Okay, now dx2 divided by dt equal to x1 minus x2. Now this, if I can write it as minus of x2 minus x1, then this dx2 by dt I can write it as dx2 by dt equal to minus of x2 minus x1. So minus of, now what is this x2 minus x1? This is nothing but dx1 by dt, x2 minus x1. So dx1 divided by dt. Now our problem is solved. So dx2 by dt equal to minus of dx1 by dt. Now when you integrate with respect to dt, you are integrating with respect to dt, you get is x2 equal to minus x1 plus some constant c. Fine. Now x2 equal to minus x1 plus some constant. Now we have written x2 of 0 equal to minus 1. So x2 of 0, I mean x2 of 0 equal to minus 1. So let me write x2 equal to minus 1 equal to minus x1 plus okay, let me write here x2 equal to minus x1 plus c. Now x2 of 0 equal to minus 1. So minus 1 equal to minus x1. So minus x1 means at x1 that is 1. So minus 1 plus c, which means c equal to 0. So I can write x2 equal to minus x1. So this is my equation, x2 equal to minus x1 or x1 equal to minus x2. Now come back to our original equation, dx1 by dt equal to x2 minus x1. Fine, dx1 by dt equal to x2 minus x1. Now I am writing in terms of x1, so I have to change this x2. What is x2 equal to minus x1? So I can write it as minus 2 times x1. So dx1 by dt equal to dx1 divided by dt equal to minus 2x1, which means x1 is equal to minus okay, so what up to there we got. Okay, what was the last okay, so dx1 divided by dt equal to minus 2x1. This is the last equation that we got, dx1. Okay, so that is equal to minus dx1 divided by 2x1 or x1 equal to minus 2 to dt. Sorry, this is not minus, dx1 by x1 equal to minus 2 dt. So log x1 equal to minus 2t plus log c would come because integration constant, integrating this Here what you are going to get is log okay, fine. So x1 at t equal to 0, x1 equal to 1, right? So 0 equal to fine, to t equal to 0, x1 equal to, so log of 1 is equal to minus 2t, so 2 times 0 plus log 1, which means c equal to 1. Now that's one part. So log x1 equal to minus 2t, so log 1 is equal to 0, right? C equal to 0, log 1 equal to 0, so I can write log x1 equal to minus 2t, and x1 is equal to e to the power minus 2t. Similarly, what is x2? x2 I got it as minus x1, then x2 will be equal to e to the power minus 2t. So x1 and x2 I got e to the power minus 2t and e to the power minus 2t. Newton's law of cooling. So this thermodynamical equation is a thermodynamical system. For example, I have got a something that is at its temperature T. It is kept in outside temperature is T0. Okay, that means a glass of water. After some time T, it will gradually reach T0. Right. Now, what will happen to this particular T, that means temperature? After some time it will reach T0. It can be either less than T. For example, I am considering the room temperature as 25 degrees Celsius, and if I keep water, that means cold water, at 5 degrees Celsius, after some time T it will reach 25. Or if I am keeping a hot water or tea or a coffee at 80 degrees Celsius in a cup, that also after some time T it will reach T0, which is the room temperature. Now this is regarding the thermodynamical system, and we are discussing the Newton's law of cooling. Now what is that Newton's law of cooling says? Rate of decay of temperature is proportional to T minus T0. What is T and T0? T is the temperature of the system, and T0 is surrounding temperature or temperature of the environment. Okay, surrounding temperature. So rate of decay of temperature, that means dt by, that is capital T divided by small t dt, is proportional to T minus T0. This is what we know. Now there is a minus sign. This is due to decay of temperature, that means temperature is decreasing. Okay, just to consider, you can either anyway you can consider whether minus T or plus T, but generally it is temperature falling we consider. Okay, fall of temperature, that is why minus sign. Okay, now this minus dt by dt is equal to some constant k into T minus t naught. Now what you have to do, dt divided by bring this t minus t naught to the denominator, equal to minus k dt. Integral. This is log t minus t naught. What is in the denominator and what is in the numerator? Dt is nothing but the differentiation of what is in the denominator. So you can directly write log of t minus t naught equal to k dt, that is minus kt plus log c. Now why log c? Because our dependent function is a function of log, that is why the constant should be of log. Now what you can do is you can write log t minus t naught divided by c equal to minus kt. Fine. From here you can write the exponential t minus t naught by c equal to e to the power minus kt. Fine. Now t is equal to t naught plus c e to the power minus kt. Fine. So this is the what so called equation for Newton's law of cooling. That means after some time t, if you want to know the this thing, you have to use it for. Now our idea is to find, or next step is to find the value of c, right? Now this is because this is an indefinite integral. Okay, that is why we do not have this value of c. And because for example, if you write at t equal to 0, we cannot write this because we don't have a data. No data is present at t equal to 0. Or we can write at sorry, this t, this is t. Okay. At capital T, and at t equal to 0, we can write, only thing that we can do is our capital T is equal to t naught, because it is initially okay, so this we cannot write. We can write t equal to t1, and after some time t, capital T equal to t2. Now let us try to integrate that. Okay. Now dt by dt equal to minus k into t minus t naught. Now integral dt divided by t minus t naught from where to where? T1 to T2. These are the two temperatures, is equal to integral, and the time is from 0 to small t, minus k dt. Now this, if I write log t minus t naught from where to where? T1 to T2 is equal to minus k t. Now here I don't need to write c because this is definite integral. Limits are given. So when the limits are given, it is definite integral. Now log t minus t naught. So substitute the upper limit first. So log of t2 minus t naught minus log of t1 minus t naught equal to minus kt. Now this log a minus log b is nothing but log a by b. So t2 minus t naught by t1 minus t naught equal to minus kt. Now this formula is what you have to remember throughout. This is Newton's law of cooling. Now where this is constant, T2 is the final temperature, you can write T2 is the final temperature, T1 is the initial temperature. Now suppose our temperature of the system is increasing, system increases, that means temperature of the system is increasing, that means you kept at T, it reached T naught, which where T is less than T naught, that means T naught is greater. Okay, then your function dt divided by T is will be equal to k into T minus T naught. Okay, if it increases, okay, there will be no minus sign, it will be plus. Here a cup of coffee at 100 degrees Celsius is placed at room temperature of 20 degrees Celsius. It takes 5 minutes to cool to 60 degrees Celsius. How long it will take to cool to 30 degrees Celsius? Okay, now here there is a little confusion. How long it will take to cool to 30 degree means the total time is asked, that means from 100 degrees Celsius to 30 degrees Celsius. The coffee from 100 degrees Celsius, it cooled it to 60, right, in 5 minutes. Okay, now from 60 to 30 there will be some time. So the question asked is the entire time, not this small letter t, not from 60 to 30 but from 100 to 30. Okay, so case 1 means the first part, that means the coffee is being cooled from 100 to 60 degrees Celsius. So T1 will be equal to 100, T2 will be equal to 60 degree. Okay, and the time taken for that particular duration or the effect is 5 minutes. Okay, you need not convert, no need to convert. Okay, no need to convert to seconds because we will get the answer in minutes. Okay, later on if the question is asked in seconds also, you can convert it into seconds, because all here in the question it is given in terms of minutes. So log T2 minus T1 by T1 minus, sorry, this is T naught is equal to minus KT. Now why minus KT? Because it is cooling down. Okay. So that is equal to log, what is the second temperature? 60 minus 20 divided by T1 is 100 minus 20 equal to minus KT, and time is 5, so I can write it as K into 5. So 60 minus 20, 40, 40 by 80. So log 40 by 80 is nothing but 1 by 2 equal to minus kt. Oh sorry, minus 5k. Okay. So now you can write, since log 1 by 2 is minus 5k, I can write log of 2 is equal to 5k, right? Inverse, if I write log inverse, okay, if you didn't get that, write like this: log 2 inverse equal to minus 5k, right? Log 2 inverse is nothing but minus 1 of log 2 equal to minus 5k. So minus minus get cancelled, log 2 equal to 5k. So that's what I have written, log of 2 equal to 5k. Now the second part of the question. What is the second part of the question says? Log of, it is cooling from where to where? 60 to 30. Either you can take 60 to 30 or 100 to 30 also you can take. If you take 100 to 30, directly you will get. If you take 60 to 30, you have to add that 5. Okay, we will do this. Log of, it is cooling from 60 to 30. Okay, so this becomes your T2, this becomes your T1. So T2 minus T1, that is, sorry, T0, that is 60 minus 20 divided by 30 minus 20 equal to minus k t, but this time t we don't know. So log of this 60 minus 20 is 40 by 10 is equal to minus k into t. So k you can write it from here, k equal to log 2 divided by 5, correct? Log 2 divided by 5. Now log of 40 by 10 is nothing but 2. So log 4 is equal to minus k is log 2 divided by 5 into t.
Excuse me, sir.
Yes.
Sir, here 30-degree temperature becomes T2 now, sir. Is the final temperature. In the second case, we have to consider 30 degree as T2 now, sir.
T2 minus, oh yeah, fine. So this is T1, this is T2. Yeah, okay, I have written here correct. No, I have not written correctly, right? Yeah, okay, fine, thank you. So this must be 30, this must be 60. So this is 1 by 4. Okay, thank you. So this is 1 by 4. Okay, yeah. So 1 by 4 is equal to minus log 2 divided by 5 into t. So log of this, I can write it as 1 by 2 whole to the power 2, or that's equal to minus log 2 to the power 2. That is nothing but minus 2 log 2. Okay, so minus 2 log 2 is equal to minus log 2 divided by 5 into t. Now this minus 2 log minus and minus get cancelled. log 2 and log 2 get cancelled. So what is remaining is t is equal to, bring this 5 to the next side, t is equal to 10 minutes. Now the time taken from 60 degree to 30 degree is 10 minutes. So from 100 degree to 60, from 100 to 60, then 60 to 30. So 100 to 60 it is 5 minutes, then 60 to 30 is 10 minutes, then together from 100 to 30 is 15 minutes. So it will take 15 minutes to cool to 30 degree when you keep it at 100 degree Celsius in a room temperature of 20 degree Celsius. Okay. Now what does this orthogonal family of curves? Orthogonal means perpendicular. If you have a straight line, its perpendicular curve is this one. So if this is equal to y equal to some a, here you may get some x equal to b or c, anything, it can be any value, all are called orthogonal families. Okay. Now what is the importance of this curve? Now the product of two slopes of the curve, so product of two slopes of two curves equal to -1, then the curves are orthogonal. This is how you represent the orthogonal curves, or whether you want to find out the orthogonal curve, then this is the basic idea that it is required. That means what is slope? Slope is nothing but dy by dx okay. Now of the given curve. Now what will be the question? Question will be, you will be given curves, that is curves 1. You will be asked to find out the orthogonal curves of 2 orthogonal curves, and let me call that as curve 2. Okay, that means the function of the curve 2. Okay, so dy by dx is given and it's this is the slope. Okay, yeah, dy by dx of the given curve into dy by dx of orthogonal curve should be equal to -1. So this is the idea. So dy by dx of the given curve, I am writing it as g times multiplied by dy by dx of the orthogonal curve, I am writing it as o, that should be equal to -1. Okay, now just for an example I will calculate dy by dx of the given curve is equal to minus x by y. Minus x by y. So what should be dy by dx of the orthogonal curve? It must be y by x.
Y by x.
Yeah. So that's minus x by y into y by x. That should. Now once you got y by x, dy by dx is equal to y by x. So dy by dx is equal to y by x. Bring this y here and you can write it as dy by y is equal to dx by x. Integrate. What you are going to get is log y is equal to log x plus log c, which means y is equal to xc. This is the function of the curve that you are getting. Now from here you can find out the function of the curve. This is the first derivative of the curve. So how will you get the function of the curve, given curve? So dy by dx equal to minus x divided by y. So y it is going here, x here. So it will be equal to x dx equal to minus y dy. That is equal to x square plus y square equal to c. This is the family of circle and this is the family of this is a y equal to xc as a parabola. Wait, y equal to x, c is some constant, right? It's not parabola. What should be that? It's a straight line, right? Yeah, straight line. Linear, it's a linear fit. This is just like saying y equal to 4x or y equal to x. Okay, yeah. Solution to linear differential equation using integrating factor. Now the general form we can write. The general form. As of the form dy by dx, where y is the dependent variable and x is the independent variable, plus p of x. That means p can be some function of x into y is equal to q of x, which is purely on x. Okay, or you can just write like this: y dash plus p of x into y equal to q of x into y naught. That means independent of y. Or even if you don't write this also is fine. Sorry, no need to write equal to 0. Okay. Now what are p of x and q of x? Now here you have to mention p of x and q of x. Now either they are function of x, functions of x, or constants. Okay, p of x and q of x, either they should be function of x or constants. Okay, fine. So now what is the solution? Solution is how will you write that? Okay, so let us write integrating factor first. Integrating factor is given by e to the power integral p dx. P dx means p of x dx. Okay, that is the p is the function. That means the coefficient of y should be your p. Okay. Right. So we have the differential equation, that is dy by dx plus p of x plus p of x into y equal to q of x. Now what you have to do is multiply by integrating factor. Now what is the integrating factor? What we have done, integrating factor is equal to e to the power integral p dx. P dx is p of x dx. Okay, now let us do that. So dy by dx into e to the power integral p dx plus this is p of x, right? P of x into e to the power integral p dx into, there is a term y, so y equal to q of x into e to the power integral p dx. Fine. Now let this particular term be equal to u dash, and this is integral p dx is v, and integral p dx and this entire term will be equal to v dash, because e to the power 3x differentiation is nothing but 3 e to the power 3x, right? This is the function. If you differentiate, it will become this. So p will come to the coefficient. So p of x into e to the power p dx will be equal to v dash. Now this is the theory. Okay, then this will be equal to integration of this. Y is nothing but integration of dy by dx. So this will be equal to u. Fine. So then we can write, what we can write is d by dx of y into, that means u into integral e to the power p dx, that is v. Let me write instead of v, e to the power integral p dx, y into e to the power integral p dx should be equal to what? q of x into e to the power integral p dx. Why is this u dash v plus v dash u? This is nothing but d by dx of uv, u dash v plus uv dash. Okay, that's what we have written in the form of u and v. This is v, this is u. Fine. So when you integrate the both sides, what you get, that means integration here and integration here. So this term will go, so that will be remaining as y into e to the power integral p dx equal to integral q of x into e to the power integral p dx. Now some constant will be there that you can use. Now so y into integral p dx, that means the integrating factor is equal to this much. So what is the solution to this differential equation? Solution is y into, what is integral e to the power integral p dx, that is integrating factor. You can write it integrating factor as itself. Integrating factor equal to integral of q of x into integrating factor dx plus c. So this is the solution to the differential equation when your function is of this form. So question is y dash plus 1 by x times y equal to x cube minus 3. Now immediately, what is the solution? Solution is y into integrating factor is equal to integrating factor into q of x dx plus some constant c. Now what is the integrating factor is equal to e to the power integral p dx. Now what is p? P is equal to coefficient of y. Now what is coefficient of y? That is equal to 1 by x. So integrating factor will be equal to e to the power integral p dx. P is nothing but 1 by x dx. That's equal to e to the power log x. That's equal to x. Now when you write the solution, y into x is equal to x into integral x into q of x is x cube minus 3 dx plus some constant c. So that's equal to integral x to the power 4 minus 3x dx plus c equal to x to the power 5 by 5 minus 3x square by 2 plus c, that is y times x. So y is equal to x to the power 4 by 5 minus 3x by 2 plus c by x. So this is y. Mechanics of a freely falling body. Now what do you mean by a freely falling body? Now when a body is said to be freely falling when its initial velocity u is equal to 0 and it's freely falling under the gravity g. Okay, now there are two forces acting on this body. One is the gravitational force g, and multiplied by the mass will give you the force under the gravity, and there is an upward force due to the resistance of the air. We will write it represent it by Fr, and the downward force we will can write it by Fg. Okay, now according to Newton's second law, you can write the net force F net is equal to there is force Fg and there is force Fr. Now what is the sign of the force? Gravitational force and the resistance force due to air. Now to understand that, consider the velocity, the direction of velocity. The velocity of the body is in the downward direction. So in which direction is the force? Force in the direction of velocity is considered to be positive. So in this case Fg is considered positive, and the force which is opposite to the direction of the velocity will be considered negative. So F is negative. Now you can write as m dv by dt, that is change in velocity by time is the force, sorry, the acceleration, and mass times that becomes the force, mg the gravitational force, minus Fr. Now what is Fr? Fr, the force Fr is proportional to v, velocity. Okay, and it is proportional to velocity. Higher the velocity of the body, higher will be the resistance force. So you can write Fr is equal to some constant k times v. So this we can write it as mg minus k times v. Now rearranging the terms, we get m dv by dt plus k times v equal to mg. Now again dividing by the mass, what you get is dv by dt plus k by m into v is equal to g. Fine. Now this is of the form dy by dx plus p of x into y equal to q of x. Now this kind of equation can be solved using integrating factor. Now what is the integrating factor here? Integrating factor is equal to integral e to the power integral p dx. Now what is that? E to the power integral. What is p here? P of x into y. Y is the dependent variable and x is the independent variable. Now here v is the dependent variable and the k by m is the coefficient of the dependent variable, which is nothing but p. Okay, so k by m, and what is the dependent variable here? That is the time t. So k by m dt. So integrating factor will be equal to e to the power integral kt by m. Now we can write the solution as the dependent variable, that is v, into integrating factor, that is e to the power kt by m, equal to integral into integrating factor e to the power kt by m into p of q of x. What is the q of x here? That is g. G is the q of x into dt, right? Yeah. So on integrating, so v into e to the power kt by m equal to g, you can take it out, g into here we can add some constant here, so g into e to the power kt by m, e to the power kt by m divided by the differentiation of kt by m, that is k into m. K by m, m goes to numerator plus some constant c. Now again you can write it as v into e to the power kt by m equal to mg by k into e to the power kt by m plus c. Now let us put the initial condition that we know. At a time t equal to 0, your velocity is equal to 0. Now when velocity equal to 0, you can write the first term will become 0 equal to time t, so that will be equal to mg by k plus some constant c, which means c is equal to minus mg by k. So this is the value of c. Now coming to the equation once again, v into e to the power kt by m is equal to mg by k into e to the power kt divided by m minus mg divided by k. Now this you can write it as, take the mg by k as the common and e to the power kt by m minus 1. Now v is equal to, divide the throughout e to the power kt by m, v is equal to mg divided by k into 1 minus 1 divided by e to the power kt by m. This is equal to v is equal to mg by k into 1 minus e to the power minus kt divided by m. Now we have the initial condition, that is at t equal to 0 our v is equal to 0. Velocity is equal to 0. So what you will do is put t equal to 0 in our this equation. This entire term, this e to the power kt by m, that t becomes 0. So 1 minus 1 becomes 0. Okay. So when t tends to infinity, when t is going to infinity, this entire term will go to 0. This entire term will go to 0. That means 1 minus 0 will be the answer. So as t tends to infinity, your v will be equal to mg by k. Now as the ball or the object moves down in the freely falling, as it reaches the ground, that means as t increases to infinity, v will go to mg by k. Okay. The graph will be something like this. If you have the velocity on y axis and the x axis we have t, then at t equal to 0 velocity will be equal to 0 and it increases and goes like this. At particular point it reaches this point, so this point is called mg by k.
A few more additional information regarding differential equations are follows. Here we are introduced to first order differential equation. First order differential equation. Okay. Now first order differential equation, and when we are talking about first order differential equation, we are focusing, or it means that first order, first degree linear differential equation. So first order and also first degree, the degree of the differential equation is first degree linear differential equation. Now in general this differential equation will be of the form dy by dx equal to some function of f of x comma y. Now you can write the differential equation of the form m of x comma y dx plus n of x comma y dy equal to 0. That means you can separate out the dx term and dy term. Okay. Now this is the general form of first order first degree linear differential equation. Now the methods to solve this linear differential equation. So the first method is variable separable method. Now here, as we know, this is our general form of this equation 1 is the general form for linear differential equation. If you can write m of x comma y, that means in the given differential equation, if m of xy is the function of only x and n of x comma y is a function of only y, some function, it need not be f of, it can be g of some function y, then you can write find the equation of or the solution to this differential equation. Solution can be found out by, you can write it as f of x dx plus n of y dy equal to 0. So the solution will be just integrating this. You will integrate this part. What you are arriving at is the y in terms of x, some functions of x. One application of variable separable method. Variable that is Newton's law of cooling. This is one of the application where you can write the log of T2 minus T0 divided by T1 minus T0 is equal to minus K times T. Now what is T0? T0 is the room temperature. T1 is the initial temperature of the system. T2 is the final temperature of the system. And T is the time taken. And K is some constant. Whose value or whose dimension is second inverse. Another application of this variable separable method is finding orthogonal families of curve. Now what does this mean is, when you have a curve something like this, you need to find other curves such that both are perpendicular. Likewise this curve and this curve is always perpendicular. Now for that you need to find dy by dx of the that means the slope of the given curve into dy by dx of the orthogonal curve. So this we don't know, but we orthogonal curve, we simply write it, this must be equal to -1. So the product of slope of a given curve and orthogonal curve gives you -1. So this is simply nothing. This is means perpendicular. Yeah. For circles, just for the example purpose, for a family of circles, straight lines are orthogonal curves. Okay, orthogonal curves. Now similarly for a straight line, its family of circle. Okay. All right. Some applications of integrating factor method that we are using in our day-to-day that we can relate to a physical phenomena are for a freely falling body. Freely falling body in air. That means in air, it means that there is some air resistance to this flow of this body. Now that means if there is a body is falling in air, there is some opposite forces or the drag force. Okay, so of some kind, it can be some constant times v or some constant times v square. So it can be any function of a v. So it depends on velocity. Higher the velocity, higher will be the resistive force. So the ball will be falling down with mg, which is the force due to gravity, and the air will be acting. That means the air resistance will be acting against this force. Now velocity is given by, velocity of this body is given by mg by k. K is some constant. Okay. Mg by k into 1 minus e to the power minus kt by m. So here mg by k, this particular term is called terminal velocity. Beyond this velocity, any body will not fall. Body cannot fall with a velocity which is greater than the terminal velocity for a freely falling body. Now terminal velocity is the velocity as t tending to infinity. Now you, instead of e to the power minus kt by m, if as the t tends to infinity, this particular term will get becomes 0 and v will be equal to mg by k. So that is the maximum velocity. Okay, all other velocity will be less than mg by k. So that is the maximum velocity. So terminal velocity is also the maximum velocity. Velocity that a body can attain on freely falling. Okay. Now let us see how we can apply the integrating factor method in electronics. For a circuit as shown, this is the resistance, this is the capacitor, and these are connected to a battery. So this is positive and this is negative, and here you have the battery source, here is the resistance, and this is C. So this is an RC circuit. Now we can write the current, let this be the current I flowing through the resistance. Then IR, by applying the Kirchhoff voltage law, you can write the IR, which is the voltage across the resistance, plus Q by C, if Q is the charge in the capacitor, C is the capacitance, then minus E will be equal to 0. So this is the Kirchhoff voltage law. So you can see that this is this can be written in the form of R dV by dr. So the next method by which you can solve the differential equation is exact differential equation. Now as we know, writing the general formula, m of x comma y dx plus n of x comma y dy equal to 0. Now if dou m by dou y equal to dou n by dou x, if dou m by dou y equal to dou n by dou x, then the solution is given by integral m dx plus integral n minus terms containing x, which means if n is equal to x square plus 2xy plus y square, you must remove all terms which contains x. So here x square to xy, so n should be equal to y square. Okay, so n minus terms containing x, and it is with respect to dy, equal to c, that is the constant of integration. So once again the solution is given by integral m dx plus integral n minus terms containing x into y into dy equal to c. So this is how to solve the exact differential. How to check whether it is an exact differential equation, you have to use this formula. If find out what is dou m by dou y and dou n by dou x, if it is equal, go with this solution. Homogeneous differential equation. Now next one is now what I mean by homogeneous differential equation is if you have some y dash, if it is given as x y divided by x square plus y square, or x square divided by x square plus y square, or x by y. Now all these are called homogeneous differential equation. That means power of numerator is equal to power of denominator. Both the power of numerator and denominator are equal, then this and that is equal to some differential equation y dash, then this is called homogeneous differential equation. Now in such cases we have to use this. You have to put y is equal to some v into x, then y dash is equal to, from this equation you get y dash is equal to v plus v dash x. Now you have got this equation, and in the beginning you already have got this differential equation y dash equal to some x y divided by x square plus y square. So this is equation 2. Now equating both, you will get the y. Another type of solving differential equation is Bernoulli's equation. Now dy by dx plus py equal to q to the power qy to the power n. In this case you have to put z is equal to y to the power 1 minus n. So y to the power 1 minus n dz divided by dx plus, so after putting y equal z is equal to y to the power n minus 1 minus n, our differential equation will take this form: dz by dx into 1 minus n into pz equal to 1 minus n into q. Now this differential equation can be solved either using integrating factor or exact differential, anything what we have discussed in the previous cases. So once we reach this stage, you can go back to any of the previously discussed type of solving differential equation. There you get the answer.